Alright, welcome back to the final question of the 2012 AP Calculus FRQ. The question goes as follows. Between time 0 to 12, a particle moves along the x-axis. The velocity of the particle at time t is given by the v of t equaling cosine pi over 6t. The particle is at position x equals 2 at time 0. So, first question. Between 0 and 12, when is the particle moving left? Well, the way to figure out if a particle is moving left is to look at its velocity. And when velocity is negative, that means the particle is moving leftward. So, what I'm going to do is, since we're given the velocity function already, I'm going to just go ahead and graph this function and find out where the function is above the x-axis or below the x-axis. Because if a function was below the x-axis, that means that that velocity's value is negative at that time. And as we just found out, when velocity is negative, the particle is moving leftward. So, if I looked at v of t equaling cos pi over 6t, a little bit of algebra 3-4 involved here. First thing I'm going to do is I'm going to find out the new period, because everything else is the same. The amplitude is 1, there's no vertical shift, there's no phase shift, blah, blah, blah. So, what's the new period of this thing? Well, to find the new period, I'm going to take the original period, and then I'm going to divide it by the frequency. Well, the frequency in this case is pi over 6, which means I get 2 pi times 6 over pi, which, hey, what do you know? 12. Cool. So when I go and graph this thing, all I have to worry about is graphing one cosine, and I know that that's going to end at 12. Halfway between that is going to be 6. Halfway between the halfway is going to be 3. And so I've got 3, 6, 9, 12. So I'm thinking that this region right here is going to be when the particle is moving left. And so that's what I'm going to write. I'm going to say the particle, change my font here, sorry. The particle is moving left from 3 to 9 because v of t is negative there. Boom. Part A. Pretty straightforward, I think. Let's move on to part B. Oh, my favorite. Write but do not evaluate. Write but do not evaluate an integral expression that gives the total distance traveled from 0 to 6. Okay, well, how do you get total distance traveled? Well, I'm going to go ahead and integrate the velocity from 0 to 6. And if I just integrated the velocity, then I'd be getting the displacement, right? That would be the change in position from 0 to 6. But as we've seen up here in the graph, the particle has negative velocity from 3 to 6. I gotta account for that. I gotta make sure that that negative area becomes positivized, because while it's traveling backwards, it's going to end up 3 spaces back from where it was at time equals 3. I still have to account for the fact that it traveled a certain amount. So what I'm going to do is I'm going to take this velocity and I'm going to absolute value it. And what that does is it gives me total distance traveled. So I've set up, but I have not solved, an integral expression. So I think that's all B is requiring us to do. So I think I can move on from here. Good job. Thank you. All right, let's find the acceleration of the particle at time t. So they want me to find the acceleration at any given time. So if v of t is equal to cosine of pi over 6t, to find a of t, I'm going to take the derivative of v of t, right? And so what's the derivative of cosine? I think that might be the hardest part of this problem here. The derivative of cosine is actually, it's not sine, it's negative sine of pi over 6t. But what they are anticipating that you're forgetting is chain rule. So don't forget about that. So what we've got is we've got negative pi over 6 sine of pi over 6t. Now, what you've just found is the acceleration at any time. However, what they want to know is the speed of the particle increasing, decreasing, or neither at time equals 4. We got to explain our reasoning. So it's not enough that I would just find a of t. I need to find a of 4. Well, what is that? That's negative pi over 6 times sine of pi over 6 times 4. Well, that's going to be negative pi over 6 times sine of, looks like 2 pi over 3. Well, going back to the whole unit circle, what's sine of 2 pi over 3? Well, sine of 2 pi over 3 is going to be rad 3 over 2 times negative pi over 6. So that's going to be negative pi rad 3 over 12. Now, actually, I don't really care what the value is. I just care that a of 4 was negative. Okay? So my acceleration is negative. And so now from here, I'm going to go and find the velocity at the exact same time. So what is v of 4? Well, v of 4 is going to be cosine of pi over 6 times 4. In other words, cosine of 2 pi over 3, which is negative 1/2. And again, I don't really care that it's negative 1/2. I just care that it's negative. And so when it comes down to explaining my reasoning as to why the particle is speeding up or slowing down, I can say definitively that at t equals 4, where'd my thing go? Right here. At t equals 4, the speed of the particle is increasing because both velocity and acceleration have the same signs. Bam. That's part C. They're both negative, so they're speeding up but going backwards. Awesome. Pretty straightforward FRQ. We just got to do one last thing. They're asking us to find the position at time equals 4. So give me a second. I'm going to clean up the board a little bit, and then we'll handle part D. All right. I love a fresh, clean board, so let's go ahead and take care of part D. All right. We're going to find the position of the particle at time equals 4. So in order to find the position given a velocity, I'm going to have to use integration. So I'm going to integrate from 0 to 4 of v of t dt. So a couple things to note. Why did I choose 0 as my lower bound of integration? Well, I chose 0 not because that's the beginning of the interval, but I chose 0 because I know the particle's position when time equals 0. All right, so again, the 0 was chosen for this piece of information, not because this is when the interval started. So if I integrate this straight up, what I get is I get x of 4 minus x of 0. Right? The change in position, the position at time 4 minus the position at time 0. This is the first fundamental theorem of calculus. Well, what do I know about some of these things? Well, I know that x of 4 is x of 4. That's what we're solving for. And I know that x of 0 is negative 2. And since I'm subtracting that negative 2, what I have is x of 4 plus 2 is equal to whatever this number is going to be. Okay, so what I have to do is I have to integrate literally this expression to figure out what this number is. So let's do that. If I integrate from 0 to 4 of cosine of pi over 6t dt, well, what do I get? Well, the antiderivative of cosine is going to be sine of pi over 6t. But if I was to straight up derive this thing again, I'd have to account for chain rule, which would kick out a second pi over 6 upon applying the chain rule. So what I need is I need something on the outside here that would effectively allow this chained out pi over 6 to cancel out. So I'm going to multiply it by 6 over pi. And what that gives me is it gives me 6 over pi sine of pi over 6t on 0 to 4. So we got to evaluate this thing. So what I've got is 6 over pi, that's just a constant, and I'm going to evaluate sine of pi over 6 times 4 minus sine of pi over 6 times 0. Well, this guy's gone, because sine of 0 is 0. Sine of 2 pi over 3 is rad 3 over 2. And I've got a 6 over pi there. So I'll just go and clean it up a little bit here. Boom. What I get here is I get 3 rad 3 over pi. That's what this integral has led me to. And that's what's going to fill the space right here. So all I have to do is to solve for x of 4 is to just do a little bit of algebra 1. Subtract 2 from both sides. And what I've got is x of 4 equaling 3 rad 3 over pi minus 2. And that is the position of the particle when time equals 4. And that concludes the 2012 FRQs for the AP exam. See ya.